like to start by saying thank you for taking the time this morning to come and, I guess, listen to myself and all the other fantastic speakers we have here at Serverless Days Cardiff. As Matt said, I'm James Cryer, lead engineer for Aviva. This morning, I'll be talking to you about the sort of journey we've been on for the last 12 months within Aviva Zero and kind of evolving our serverless architecture. I guess in the previous talk, Tom was talking about the DVLA, maybe coming from a different perspective, where they had an existing application, legacy applications, and they were evolving those. Aviva Zero very much comes from a position of a greenfield project, where we're now starting to consider some of those teething problems we have. Oop, my clicker's not working. So yeah, as I said, I'm James Cryer, lead engineer for Aviva. I've worked in the industry for the last 2 decades. I've worked for organizations like the BBC and Sophos. I think it's fair to say for the last 10 years, I've predominantly worked with serverless technologies and serverless workloads in Google Cloud Platform, and then more recently with Amazon Web Services. In April of 2023, I joined Aviva and as part of the Aviva Zero team. So before we get into some of the technicalities, I'd just like to introduce Aviva as an organization, for those who might not be familiar who we are. So Aviva has a presence in over 16 countries, and we have 33 million customers in total. We're headquartered in London. And we have a rich history as a business. We have over 300 years. If you actually look back in history, you can find traces of Aviva that dates back to 1696. Our mission basically is protect things that matter most to our customers. So whether that may be themselves or their health, their family, their home, or their financial future. So next up, I want to talk about Aviva Zero. This is the product I work for. Aviva Zero is a greenfield cloud-native platform that delivers motor insurance products through price comparison websites. If you've seen our logo before, it's more than likely you've seen it on one of these price comparison websites. That's the sort of entry point at which we sell to customers. So, a little history about Aviva Zero and where we've come from. So, Aviva had a desire basically to create a new motor insurance challenger in the motor insurance market, and then its planning for that product started in 2021. As you can see from the slide, the timescales around product development were quite aggressive. So planning started in February of 2021. The first commit was pushed basically later that summer, and then roughly 12 months on from that, the product launched in 2022. Since then, we've grown from strength to strength, and we continue to ship new features and build the product out. And today, I think we have roughly over 500 million customers, and soon fast approaching our 1 millionth sale. So I guess, what is Aviva Zero as a product? Lots of you probably have motor insurance. The slight difference with Aviva Zero is when you purchase your policy, we'll offset the emissions from your vehicle for the first 1,000 miles automatically. We then give you as a customer the option to offset 50% of the remaining emissions on your vehicle for that 12-month period. If you do so, Aviva will then match that 50%. So effectively, you're offsetting 100% of your emissions for your vehicle for the full 12 months. So, I'll start getting some of the technicalities. So hopefully you recognize some of these logos behind, but this kind of gives you a really good overview of how we've built Aviva Zero. We are on Amazon Web Services. We primarily write our back-end services in Go, and our front-end technology is Next.js with TypeScript. In terms of Amazon Web Services, we use the best-in-class of cloud-native serverless technologies, things like EventBridge, API Gateway, Lambda, SNS, SQS. Data storage, we exclusively use S3 and DynamoDB. And for our front ends, like I said, with Next.js and TypeScript, and we deploy that onto the ECS Fargate. And then in terms of how we ship our application, we use CDK, so AWS's CDK, and we write that respectively in both technologies, depending where you are in the application stack. So I thought it's probably important to cover kind of the common patterns we have in our architecture. I'll run, sorry, you can't really see that too great, but the top row is EventBridge. So we have EventBridge, which is choreographing events, which then is consumed by Lambda. And then if that workload basically needs to produce or persist some data, we use DynamoDB. And then off the back of that, we'll have a DynamoDB stream, basically emitting an event, whether that be through EventBridge or through via a Lambda processing that stream itself. Another common pattern we have is API gateway with Lambda, and then again, the workload from the Lambda is then persisted in DynamoDB, and if for any forward event or data processing, we have a DynamoDB stream, which then gets picked up and processed. I guess we have those two patterns because obviously we have to service APIs. For example, if when you go to an aggregating website, you type in your details, hit the button, that sends an API request from the aggregator to us to start generating that quote process. In terms of where the customer interface with us, we have front-end technologies. We have an application load balancer with a Fargate task, which then interfaces into an API. We label that the sort of back end for front end is a layer that we use for authentication and authorization in our applications. Effectively is the gateway into our back end services. I think it's important to highlight that in production today we have over 100 services and we're running 500 lambdas or 500 plus lambdas now. So we've grown quite a large ecosystem. So for the majority of the rest of the talk, I want to talk to you about this process, which is the NCD proof validation. I'll take you on a journey of how in the last 12 months, where we started and where we've migrated to over that period. So for those who may have never taken motor insurance out or aren't familiar with the concept of no claims discount, effectively a no claims discount is a discount that's applied to your policy when you purchase a policy based on the number of years you've held a motor insurance policy without making a claim. So if you've had a policy, say you've been insured for 2 years, you've never made a claim, then you start to essentially get a discount when you buy your third year's insurance. So yeah, I want to talk to you about this thing. So when I first started at Aviva Zero, the head of product came to me and said, James, we've got a problem of scale. And this wasn't scale in a technical capacity, but a scale in a kind of operational capacity. If you remember back to the sort of time frames, we had what, 7-month build, so not everything was optimized and not everything was kind of automated. So one of those processes was the NCD proof validation. So effectively, when you buy a motor insurance product, you tell us that I've got, I don't know, 5 years no claims. We then integrate with a third-party company called LexisNexis to validate that. In 85% of the cases, we can match, that number to LexisNexis, and that's fine. The customer goes through, policies all set up. But the remaining 15%, we have to basically validate it and reach out to the customer and start engaging with them to get proof of that no claims discount to make sure we can effectively apply the discount to their policy. So in the first iteration of Aviva Zero, that wasn't automated. We were asking customers to effectively email that proof to us, which I guess maybe in 2021, 2022, you can imagine that'll be fine, right? We've got a handful of customers. We're still growing as a business. Fast forward to 2023 or late 2023, more customers, that email inbox is starting to grow. And why is this a problem? Well, on day 28, if the NCD proof hasn't been validated, basically the policy gets cancelled. So we had a real potential of impacting customers by cancelling their insurance product, when effectively the customer wasn't at fault, it was us in terms of process. So we knew we needed to kind of automate this process and go through a process of making this self-service effectively. So as with most things in technology, you don't want to reinvent the wheel. So we looked around Aviva Zero and tried to figure out where we had a similar pattern, effectively allowing customers in an authenticated experience to upload files to our service. Luckily for us as a team, there was an existing experience. That was the claims handling experience. And this is largely the architectural pattern they followed. Effectively, point one is an S3 bucket. So when the customer logs into Aviva Zero, They try to upload a file, that generates a pre-signed URL, which denotes which S3 bucket. The file lands in S3, this then triggers basically clam AV to scan the file. And then the output of that scanning event goes to EventBridge. Depending on that result, it either goes down the positive path or I guess the failure path. If it goes down the positive path, we move the file into this bucket at point 4, which is known as a trusted bucket. Trusted because we can then allow our operations staff to start investigating that. So we're good, we've got something there, customers aren't going to get cancelled, they can now start self-service and good, solve the problem. But even though we were following an existing pattern, I guess as time evolves, standards improve, and our CISO was like, actually, we're not doing enough here. We need to improve our security posture. So what can we do, basically, to harden this process? So we started looking at features, basically, that we wanted to build into this pipeline and then basically harden that file processing to ensure that when somebody uploads a file, it's not only valid, doesn't contain any malicious code, but also protect customers from disclosing information to us that they might not want to. So we aligned these 6 goals. So first is MIME type detection. So basically checking if the file that the customer is giving to us is the file that they actually are. The type of file is actually what they're advertising. For example, they haven't renamed the file to something else. Then very rudimentary file extension allow lists. Well, just checking extensions within our allow list. The next one is file size validation. So basically, we don't want 0-byte files, right? Because that's kind of data. No point in wasting operations time investigating that. Quick feedback loop to the customer. Equally, we are talking about a document. We shouldn't have large files coming into our system. Again, not really space. We want to filter that early in the process. And then the next one is about privacy. Basically, there's no need for Aviva to hold any sort of location-based data on those images. And you're probably thinking, why do we have images? Well, not all insurers issue these documents digitally still. Some still send them in the mail. So customers use their smartphone, take a camera photo, and then upload it. Obviously, that largely will contain the location information. So we wanted to strip that out as part of the pipeline. The next one is destroy and recreate. So effectively, we've done all these checks. We think it's the file type that we want. We think it's in the allow list. It's of the right size. But basically, we want to validate this file doesn't contain any malicious code in addition to what is an actual valid image. So the principle is you take a service that basically takes the image data and then recreates it from just the image data, the output then being a clean, sanitized file. Then finally, content filtering. Again, this was more of a protection for our colleagues. We didn't want, I guess, any obscene content or any sort of nudity or violence to basically land in front of our colleagues' screens. So we wanted to make sure we had some sort of level of protection there. So I guess now we have these 6 things we want to do. We had to start reasoning with how we were going to build this thing. And up until this point, we only had those patterns there where you've seen EventBridge API Gateway. I'd worked with Google Workflow in a previous role, and I was very much in the space that we needed to start to experiment with StepFunctions. Primarily because, as you can see, even though these 6 features are quite small, they do sort of form a pattern of a workflow. You want to do these checks at certain points on particular types of files. So we started to have discussions around step functions and whether that would be a good evolution for us. So I guess aside to this, we need to do this improvement alongside our other functional changes as well. So we needed to build up workflow whilst also delivering features on another part of the project. So why do we choose step functions? I call these 4 key points out, really. So the visual editor, we felt would be really positive in this sort of collaborative space. Be able to sit down as a team, work through it in the AWS console, and map out this new workflow for us. Seemed like a really attractive feature. We thought it would accelerate our development lifecycle. As I mentioned, there's 2 upload processes. We have the NCD upload, and we also have the claims. So having the solution we built, we wanted to be able to backport that for claims as well. So that having that component reuse seemed like a really powerful thing for us as well. The third point, SDA integrations. We were a new team to StepFunctions, so at the first outset, we weren't too sure if we were going to use them or how we'd use them. But we thought that seemed like an attractive offering, reduce the amount of code we had to write ourselves, again, to accelerate that development lifecycle. And lastly, the real-time and auditable workflows. Well, being a new team, working in a new service, we wanted that clear observability and be able to trace where failures were happening in that workflow process. It seemed, again, like something that would really benefit us, A, in the development lifecycle, but also in the operational space when we actually shipped into production. So with that said, we set about and started to design this workflow. And this actually isn't in the StepFunctions console, this is in Miro. So we came up with this concept of how we wanted to process files. And the important part here is to call out point 1. So basically, you probably can't see, unfortunately, on the slide, but point 1 is where the existing scanner is happening. So this is the existing workflow. So basically, the AV scanner would scan the file, and off the back of that event, we would then trigger a StepFunctions workflow. The second point is basically where we make a decision. Is this file successfully passed scanning or not? And you're probably thinking, excuse me, why would we do that? Why are we invoking the step function just to check whether the output, the scanning result is, we could have bypassed the step function altogether. But ultimately, we wanted to centralize all processing through one common workflow orchestration tool. So the first step is, as it passed scanning. The second step is basically performing those image validation steps and basically determine, is the file we're processing really an image? And if it is, then send it down a particular path, basically. Then that's on to point 3, basically, where we start to do the destroy and recreate step. If we successfully pass the destroy and recreate step, we then pass it on to our content filtering process. If that all passes, we then emit an event out the door, and basically systems downstream will start processing those events. So I said, this is the initial design. This is what we essentially took out to the technical leadership and the other teams to kind of get approval to proceed forward. And then we ended up with this, we ended up with this workflow. So this is a direct export from our StepFunctions console. This is basically the output of the ASL file. And largely speaking, it does marry up with the design on the previous slide, but there's some subtle differences here. So if you look at point 1, you'll notice the icon there is slightly different to the rest. You can see the orange of the lambda, and then you've got point 1. This is where we start to look at direct integrations. As part of that collaborative process where we're in the console, we started to realize actually these direct integrations are going to save us a lot of time. Then on to point 2, this is another feature of StepFunctions I actually love. It's the pass state. It's really simple, and we'll come to why it's really good. But it allowed us to form a common way of expressing failure in our pipeline, or our file verification process. Then point 3 is the same as point 1, basically more direct integrations. If you remember on the previous slide, these are all lambdas. We've replaced those lambdas effectively with direct integrations. So we now have this step workflow, but we've got a problem. We need to ship this to production without impacting customers. And we were slightly hesitant. We weren't running recognition in production in any of our other workloads, so it was our first time using recognition. What we did want to do is launch this new workflow with recognition in it, and then basically start rejecting legitimate files, because that would be a really negative space, right? Basically, effectively, we could end up canceling people's policies for our own failings. So what we wanted to do is ship this workload into production and basically monitor it for a period of time, get some feedback. So we devised a plan. We have this Lambda function that scans a file, puts the event onto EventBridge. Then what do we do next? Well, we wanted the current experience to carry on working. That's the lower line where the Lambda is invoked and downstream process happens. But then we fan the event onto a new event bus. We wanted that mainly for isolation. So basically, the event flows from the shared bus onto a dedicated sort of experimental bus, I guess is the best way to describe it. And then that experimental event would then basically trigger the step function. There are other ways of implementing this, but for us, that felt like a safe, clean path for us. I guess it's good to call this out in terms of serverless, because the actual value in being able to do that sort of orchestration of development is really powerful. Maybe traditionally in systems you wouldn't be able to achieve that. Running these systems side by side with very little extra cost seemed like a real good benefit for us as a team. And we gained really valuable insights. So We now have a deployment model, we have a workflow, all's good. And I want to go backward step back into this SDK integrations. So like I said, what we found when we started working with them is they dramatically reduced our development time. If you actually think back to the workflow, we had 4 key areas basically where we weren't writing Lambda code anymore. We were now just basically using direct integrations to ship our workflow. Now, that might not seem massive, but if you think about the amount of testing and maintenance of those Lambdas, that can become expensive over time, especially if you replicate that over the 100 services we have. So having these direct integrations really accelerated our development lifecycle. It reduced glue code. I actually think it does really benefit teams in sort of experimenting with new AWS services. It feels like that barrier to those services is slightly reduced by using these direct integrations. So what does one look like? Sorry, you really can't see that. So you'll have to imagine it, sorry, but so on point 1 is essentially where we invoke the, so this is basically about 20 lines of JSON or YAML, and that's all it takes basically to invoke recognition as a service. So we want to use recognition as a moderation service. Basically with these 20 lines of YAML code, we can basically pass the S3 object at point 1, and then get the result at point 2, do some transformation inside the workflow, and then pass that into the rest of the workflow, and then use that as some decision-making process further along the line. Now, I think you'd find it really hard to write that level of integration in a Lambda without writing tests and then maintaining that. So, yeah, a real powerful feature to have in your arsenal. Another thing I mentioned earlier was parse state, another feature of StepFunctions that I love. And it's really simple. In theory, you have a workflow state. But why is this really good? Well, if you imagine a workflow where you're receiving data from multiple sources, all in different formats, but you want to now standardize that data, sort of forming an anti-corruption layer within your workflow, then parse state can help you because you can take your JSON structure and then transform it into a new structure. Like I said, simple but effective. If you think about removing this feature from your workflow, again, it would be another Lambda, another 100 lines of code, probably written code you'd have to test and maintain. So I mentioned that we wanted to ship this workflow into production and get feedback. And whilst that's really good, I guess we needed to start testing this thing. So obviously, in the initial first version, we did unit testing as you do. So we unit tested each individual Lambda, and that worked effectively. We created some rudimentary integration tests, basically a set of images in S3 and fired that. But then we used that production lifecycle basically to start iterating on improving things and fixing bugs. So anything that failed in production for the first few weeks, we then basically integrate back into our integration or unit test suite. I called out the test state API. We haven't necessarily used it as part of an automation process, but you can. We used it in the early stages, basically when we were debugging and trying to understand how StepFunctions was working. The other thing to call out is you can run StepFunctions locally as well in Docker, and you can actually stub out services like SQS and DynamoDB if you need to. Again, not something we've explored, but if you needed to, that is available to you as well. So that's the workflow. We've shipped to production, we've tested it, validated it, it's in a good space, we've enabled it. So now we're in production, we're now processing thousands of these NCD approvals, which is really good. The risk of somebody basically having their policy cancelled is eliminated because we're now processing things on roughly a 3-day cycle. All well and good. Are we done? Not yet. As a team, we like to strive to keep simplifying things and keep improving things. So, in June of 2024, Amazon announced malware protection, GuardDuty malware protection for S3. As a team, we often follow the Amazon service announcements and basically are keen to look at opportunities that these new services or releases offer to us. GuardDuty scanning from S3, malware scanning for S3 seemed really attractive, and we wanted to start investigating this and seeing if we could integrate this into our workflow. So we did some due diligence. Does it offer the same capabilities we have today? What's the cost model? Is this cost going to work for us, or is it going to blow our plan out? After initial checks, that worked really well, and it fitted the model. It wasn't going to cost us. The cost was going to be tenable. And why do we want to do this? Well, the ClamAV stack itself wasn't something that we developed at Aviva. It was an AWS Labs project. And although it worked and fulfilled a capability, we didn't have an appetite to maintain that. So looking at this new offering from Amazon, the malware, GuardDuty malware scanning, it seemed like a really attractive offer. We could offload that responsibility onto a managed service with Amazon. And this is basically how we started to ship it into production. So again, we were in a scenario where we've got lots of files flowing through production. We want to release this with minimum downtime or minimum impact to customers. So we took a slightly different approach this time because it actually doesn't relate directly to the workflow itself. So on the left of the diagram on point 1, we have a Lambda basically that generates that pre-signed URL. As I pointed out in my earlier slide in the tech stack, we use LaunchDarkly as a feature flagging service. So what we wanted to do basically is control where our files flowed, either to the existing bucket down the ClamAV scan, or basically to this new bucket, which basically would be scanned by GuardDuty for us. The benefit of using this new service, and luckily for us, the integration pattern was the same. Effectively, the output was basically an event into EventBridge. So we knew that we'd have really minimal changes within our system. I think we had to make some real minor changes at point 4 just to basically transform the event out of GuardDuty into a standard format that we'd use, which I guess is really minimal in the grand scheme of things. So yeah, we set about this. I think it took us about 2 or 3 days to spike, just understand how we'd integrate this into our workflow. And then I think it took about a week of an engineer's time, and about 2 weeks ago we shipped this into production. I think it's important to call out, I guess, another thing that another benefit we didn't anticipate as part of this process was a performance increase. So by switching to GuardDuty malware protection for S3, basically we've reduced our scan times by 4.5x, basically. So there's not just a positive impact for engineers, we have less maintenance, but also we now basically have faster scan times. And it's important to point out customers actually wait for that scan to complete. So effectively, we now have a really good customer experience as well by migrating across. I guess the other thing that's really important to call out is the StepFunctions workflow. So effectively, those two workflows are the same. We use CDK, and we can replicate that. I guess it plays back into that benefit of StepFunctions, that reusability and the component reuse. Basically, we can have a common step function definition, and then we can configure that in CDK fairly easily and deploy it twice. I guess you could say, why would you want to deploy it twice? Well, from an observability perspective, we can monitor those two separate workflows independent of each other and have much more targeted alerts. So what's next for us? We continue to review other workloads now. We're looking at things like our renewal quote generation to see if step functions would be effective there. Again, a process that basically orchestrates about 7 services, and the outcome is a quote, communications. Having that mapped in a visual way and be able to debug that in production seems really powerful for us. And then we are now starting to explore generative AI and using that basically, as you probably realize, even though we're doing moderation on a file, we're not actually checking the contents is really something we're really interested in. Moderation is good, but we want to start basically interrogating that file to understand, is it a letter? Is it a no claims letter? So we're going to start looking, and we have started experimenting using generative AI and Bedrock with a direct integration into a step function workflow file. So hopefully initial tests have been positive, and yeah, we're going to take that forward as a product idea and play that out over the next coming weeks. So I just want to wrap up quickly with a slight detour into policy lifecycle. Yeah, so I've covered NCD, that's all good, we've iterated. So another part of our architecture that we've started to explore is the policy lifecycle. As you can imagine, an assurance policy goes through a number of steps and a number of triggers. We have touch points throughout the 12-month period. For example, NCD at the start, but renewals at the end. We want to engage customers at day 28 before they renew with a renewal quote, or to remind them that their policy is going to expire in 28 days. So there's a series of events that happen over the life cycle of their policy. So we now want to start to, So when I started Aviva, we have this common pattern, basically, where when a policy gets created, we basically create an index in DynamoDB based on a date. And then we have another process that runs on a nightly basis, scanning for those indexes. Then pulls all the records out of DynamoDB, and then processes them and sends them off downstream. While this isn't inherently wrong, it does have some failings and can be built in a way that's unscalable and cause problems, even in a serverless world. For example, you do have a soft limit on your concurrent Lambda invocations. We have had cases where basically where engineers haven't thought around this, we basically consumed that capacity, which then obviously impacts other services in your overall production workloads. So if you think back to the timeline, Aviva Zero was built in 2021, and technology moves fast. Amazon is always announcing new service offerings. EventBridge Scheduler wasn't a feature. So now we're starting to migrate some of our scheduling over to EventBridge Scheduler. Again, what we're trying to do is essentially reduce the amount of code we're running and rely on a managed service to deliver that offering. We have other benefits of using that managed service. It's obviously scalable for us, but also it has features like flexible time windows. So basically, you can spread the load automatically. I guess you could achieve this with our existing pattern SQS, but this feels like a much richer experience, and the cognitive load for engineers is dramatically reduced. I guess the other one thing to touch on is the ability to schedule things at any point in time, right? The model of DynamoDB, we can truncate by hour, by day, etc. But with EventBridge Schedule, you can target a much more granular point in time, and you can spread that load if you wanted to. Or, like I said, you can use the features of EventBridge Scheduler itself to do that. So I'm trying to wrap up really quickly with some final thoughts, hopefully from some ideas that you can take into your ways of working. So yeah, I guess whenever we tackle problems these days, I guess there's a trade-off between choreography and orchestration. So do you want something loose with EventBridge, or something more tightly coupled with an orchestration workflow, predominantly using StepFunctions as that tool? Feature flags are your power tool, so all this stuff I've presented today would not be, or we wouldn't be able to have a smooth transition into production without feature flagging. We're about 40 engineers all working on Aviva Zero. We need to feature flag things so we can have that high release cadence. We ship multiple times a day to production, and lots of teams are working across multiple areas. Consider your deployment strategy at the outset. So basically, before you embark on something, really think how are you going to get this to production without impacting those customers. Again, in a serverless world, it's become slightly easier, as you can obviously, like you've seen, deploy multiple versions of something or multiple workloads. Strive for simplification. That's what we're always trying to do. We're trying to offload that, I guess, undifferentiated heavy lifting to Amazon and allow us to focus on delivering features for our team. And then continue to innovate, look at those new service offerings. What can it help? How can it help you achieve that simplification, or other greater capabilities? Are there performance improvements like we see with GuardDuty? So I'd just like to thank you all for taking the time to listen to me this morning. It's been a real pleasure. Thank you very much.